I had a few more comments regarding the example that we saw on page 173. F of x was equal to 2 to the x power. G of x was equal to 1/2 to the x power. But interestingly, 1/2 to the x power can be rewritten as 2 to the negative x power. So I would like to show you a comparison between 2 to the x versus 2 to the negative x. Let's read the two blue boxes that are in the learning workbook. All right, the first one says, tip. In intermediate algebra, we learned that a to the negative n equals 1 over a to the positive n. So, for example, when we evaluate f of x equals 2 to the x power for x equals negative 3, we get f of negative 3 equals 2 to the negative 3. And 2 to the negative 3 equals 1 over 2 to the positive 3, which is 1/8. So we get the ordered pair negative 3, 1/8. Now, let's extend this idea further. Note that 2 to the negative x could be written as 1 over 2 to the x, which is the same thing as half raised to the x power. So we could write that g of x, half to the x, is the same thing as 2 to the negative x. So let's make our comparison here. We've identified that f is 2 to the x power, and g is 2 to the negative x power. How are those different from one another? Well, we notice that what has changed here is that a negative shows up. And if you remember your transformation properties, when the change is a negative, that's indicative of a reflection. So, the change is a negative, but where is it? Is it inside close to x, or is it outside far from x? The answer is inside close to x, which makes it a horizontal reflection. Horizontal reflection, that's something like this. That means we're spinning around the y-axis. So if you take a look at these two graphs, you'll notice that indeed f of x and g of x are almost the same, except that there is a horizontal reflection, a spin around the y-axis. If you spin f around the y-axis, you get g, and if you spin g around the y-axis, you get f. All right, one final thing to talk about. Raising to the 0 power. Tip, any non-zero number raised to the 0 power is 1. 2 to the 0 equals 1. 3 to the 0 equals 1. 4 to the 0 equals 1. 5 to the 0, 6 to the 0 equals 1. 2.9 raised to the 0 equals 1. Pi raised to the 0 equals 1. E raised to the 0 equals 1. But 0 raised to the 0 is undefined, and you'll learn why in calculus.